All right, welcome everyone. My name is True Mai. I'm a visiting fellow at ESIG from the National Renewable Energy Lab. Welcome everyone to ESIG's webinar. For those of you who are not familiar with ESIG, the Energy Systems Integration Group, we are a membership-based nonprofit organization providing our members with objective information, resources, and networking opportunities in support of energy systems integration. We do this through workshops, tutorials, webinars, blogs, working groups, and task force activities, and producing technical resource materials. For those of you who are members, thank you for your support. It makes possible these webinars and other work that we do. Using this opportunity, I would like to bring your attention that we recently had our fall technical workshop in Philadelphia, Pennsylvania on the week of October 27th. The workshop hosted a mix of technical content with a special topic workshop focusing on large loads integration on October 30th. Presentation materials are already posted on our events page, and the recordings have been posted on our YouTube channel. Our workshops and monthly webinars are open to everyone, so please feel free to visit our website at esig.energy or find us on LinkedIn, YouTube, Facebook, and X. Just a few logistical matters before we get started. First of all participant lines will be muted for the duration of the webinar to avoid any unnecessary distractions. But for the Q&A, please use slido.com. You can see the code there, ESIG17 at the bottom of the slide. You'll see a thumbs up button next to the questions to allow you to cast your vote and prioritize the questions that we'll be addressing. We will also have a short poll during the webinar, so it might be good to join Slido early so that you're ready for that poll. We'll save 15 minutes or so at the end for Q&A and then wrap up at the top of the hour. An email link will be provided once the video file has been posted. We will provide short responses to those questions that we didn't get a chance to address here, so please don't be afraid to ask your questions through Slido. So with that, I'm going to introduce our topic and speakers. Load growth, especially from data centers and other large loads, are having a major impact on nearly all aspects of power systems planning and operations. This is true because of the scale and speed of the expected growth. You'll hear some of that from our speakers. The size of the individual facilities, which in the largest facilities can be equivalent to a city's worth of electricity demand. The physical nature of the loads interface with the grid and other new characteristics that, quite frankly, the system hasn't been familiar with in the past. With that, ESIG formed the Large Loads Task Force about a year ago to address these important issues and to help inform the efficient integration of large loads to the power systems. The webinar today will present findings from the first report from the task force titled Forecasting for Large Loads, Current Practices and Recommendations. Long-term multi-year load forecasts are used to inform resource and transmission planning. Thus, improvements to the accuracy of the forecast can have really significant benefits. During this hour, you'll hear about a subset of the task force's recommendations for improving such forecasts, and the soon-to-be released report includes many other findings and recommendations. Future webinars will include presentations from the other project teams from the task force, which you'll hear more about from our first speaker and overall lead of ESIG's Large Load Task Force. With that, I want to introduce Sam Morris, who's the Manager of Load Forecasting and Analysis for ERCOT, the Electric Reliability Corporation of Texas. Before joining ERCOT, Sam worked as a load forecaster for NYSO, ENVA Power, and Dominion Energy. He started his career as a meteorologist with the U.S. Air Force. Our main speakers, you'll see on the slide here, are John Wilson and Sophie Meyer. John is Vice President at Grid Strategies. He specializes in planning, rates, and other utility regulation issues. John is a lead author of the recent Grid Strategies report tracking utility and regional demand forecasts. You'll hear a little bit about that from John in a bit. With 18 years of experience in utility regulation, John consults for consumer advocates, state commissions, trade associations, and others. John holds a Master of Public Policy from the Harvard Kennedy School, and John has been leading our load forecasting project team within our task force. And Sophie Meyer is also here from Grid Strategies, where she's the Director of Power Systems. She specializes in a suite of power system planning topics, including forecasting, and provides expertise across a range of utility regulation issues. Before joining Grid Strategies, Sophie worked for Form Energy and the California PUC. She holds a master's degree in material science and engineering from Stanford. So just a short reminder, once again, please use slido.com. E617 is the code down there to enter your questions. And without further ado, let's go ahead and get started. I'll turn it now over to Sam.
Good morning, good afternoon, whichever side of the country you're on here. We started this about a little over a year ago now, and kind of looking at how things start with the load interconnection queue for ERCOT. Even this year alone, we started off at 83 gigawatts and have now ballooned out to 225 gigawatts of requested large load customers. The vast majority of that being data centers. That just kind of emphasizes why this is so important. And we can go to the next slide. And the task force itself is comprised of interconnection process, interconnection performance, kind of dynamic modeling requirements, the transmission planning of things, the resource adequacy planning, and also market and operations. So when it gets there, but where does it all start? It starts here at load forecasting, which is why this is so great that this is the first to come out, right? Load forecasting, you got to know where you're going before you can figure out how you're going to do it. And I think that this team has done an excellent job of getting everything together and bringing together some of the best ideas, and has a very, very thorough recommendations list. I am very, very proud to be part of this. So with that, I'll turn it back over. Thanks, everybody.
Great, thank you, Sam. And it's John Wilson again. I'm really excited to be getting ready to release this report. I think we'll be releasing in a few days here, and had a lot of great participation that we're going to talk about here today. So let me just jump right into this. So first of all, just to give you a little background on how this report is put together, as with every report at ESIG, there is a project team of some kind. We're highlighting here the names of the people on the editing committee. It was a very large project team, so we thought we'd just focus on the folks who really kind of jumped in and really helped out with the writing process. And you can see it's a wide variety of people from lots of different institutions around the country, different kinds of institutions. We got a lot of different input, including 17 webinars from utilities and regions across the country, including Sam, who you just heard from, gave one of those webinars. So we really appreciated all of that input. So a lot of hours on the webinars, learning about what's been going on, and then turning that into the report you're going to hear about today. So just to give you a little bit of a perspective on where we're at, as True mentioned, I'm Vice President at Grid Strategies, and we recently put out a report that some of you may have read that sort of summarized the load forecast across the country. And what we found is that annual energy use growth over the next 5 years is now forecast to grow at an annual rate of 5.7%. And that's the highest since the 1960s, if that comes to be the case. So we're seeing really a lot of substantial load growth. You can also see on there a little blip for the past few years where we've been growing at nearly 1% per year at the beginning of this decade. So it's really about to take off is the projection from the utilities. And, one of the questions that's certainly been raised in the media is how accurate is this forecast? And load forecasting accuracy is, of course, a really big challenge. And to put this in perspective, back in the 2000s, the 2010s, and really even in the early 2020s, the main load forecast, of course, was the econometric load forecast that utilities used to sort of look at population growth, economic growth, and maybe a few other statistical factors, and use that to project out what's coming over the next few years. But this 5.7% is driven almost entirely by large load growth. That's the vast majority of that growth all across the country, in most utilities and most large regions, certainly nearly all large regions. So the vast majority of that load growth coming from large load growth, we recognize that a lot of new practices are having to be developed on the fly very quickly. And so that's what we're digging into here today is how do you come up with this number and what can be done to improve those practices going forward, given that many of those practices for many utilities and regions didn't even exist 3 or 4 years ago. So just to kind of give you a quick overview of how this process works, sort of maybe in a semi-ideal state. So currently we have, and I'm not sure why this heading is here. Sorry, I think we've had a little editing here. The current approach, the data inputs are interconnection request, historical data, and external data. That's the key information that we bring in. And the project metrics that we use, and we'll go through these, are listed there. We're going to go through those in a slide in just a few minutes. And that's what's used to create the peak load forecast, which drives transmission planning and generation planning. And then also those data, particularly the last one, the load factor or shape, are used to drive generation planning. What kinds of resources are needed to serve all the load? So this is kind of how a load forecast develops for a large load, for the large load component. There's a very different method that's used for general residential and commercial load. And so we're going to be focusing on this process today. We have 10 recommendations in our report. I'm not going to go through all of these right now. What I am going to do is encourage you again, as True did, to go to slido.com and enter the code E617. And when you do that, you're going to see there both a Q&A section and also a poll. And instead of going through all 10 recommendations, we're going to hit a few highlights, and then we're going to pick out the top ranked recommendations from the poll and go into those just a little bit deeper, kind of right there on the fly for you. So I think that should give you a chance to sort of let us know what you're most interested in understanding a little better. So you can open that up now and watch as we go through this. Next, I'm going to turn it over to Sophie Meyer, my colleague at Grid Strategies, and she's going to talk about sort of what's going well with load forecasting with large load forecasting right now. Sophie?
Thanks. So as John mentioned, we reviewed dozens of utility and other planning entity practices to put together a survey effectively of what current load forecasting practices look like for large loads across the country. And the good news is that a lot of things are in fact going very well, and forecasters are working very hard to adapt their practices to meet this surge in large loads. So the first thing that we really want to highlight is that large load forecasts are almost never the same as the large load pipeline. So those pipelines are basically all of the load requests and load interconnection requests that utilities and other planning entities are getting. And utilities and other planning entities, and I'll just start saying utilities rather than saying and other planning entities. And I apologize to the RTOs and ISOs and other folks, but that seems to exclude. I mean to include you. Are really being discerning. And as you can see in this Dominion Energy graphic, you can see that their requests are much higher than the actual forecast, which is the line that they're putting out. So they are cutting back from the request to what they think is actually a reasonable forecast. Next slide, John. Next, the forecasting practices across the country are almost all under active reform. So I think that there is a general consensus that improvements are needed here. And we're seeing a lot of entities take really significant steps towards improving their practices, improving transparency, improving consistency, so that we can continue to get more accurate forecasts. Next slide. And the other thing is that forecasts are generally aligned with the large load type. So as these large loads become more common, the distinctions between the types, like your data centers versus your industrial versus your oil and gas loads, are increasingly important. And utilities are moving towards collecting that data upfront so that they can make informed decisions about how to treat those loads. Next slide. And along with that, there's a really substantial investment in studying data center loads. We've seen work at NERC, for instance, where they're really prioritizing understanding the operational risks of these large loads on the grid. But there's also consideration of front-end planning risks and how these loads failing to materialize might transfer some of that cost to consumers or cause other problems on the grid. And then finally, utility rate tariffs across the country are looking to address those kinds of risks. They don't address all forms of risk to consumers and to the grid, but starting to put in place rules about how we treat these loads and requirements on those loads that they make a real showing that they reach a certain level of readiness before moving forward does help address, in particular, some of those front-end risks. In terms of what's not going quite as well, if we go to the next slide, we've identified areas where we need more improvement. So as I noticed or mentioned already, consistency is a big issue. Large loads aren't being described or assessed in the same way across all load forecasts, and even within load forecasts in single regions, we're seeing a lot of discrepancy. So that's an area where we could see major improvements. Next, we simply lack really good data. This is in particular an issue for data centers in general, but then also the different types of data centers do behave quite differently and materialize differently on the grid. Early process customer data is often unreliable, whether that's optimistic or simply due to supply chain issues. We can't take that always at face value, and forecasters need to adjust. But at the same time, utilities lack really useful historical data since this is such a new phenomenon. Alternative site data, while increasingly jurisdictions are requesting that the developers share information on whether they're looking at other sites, that's not consistent across the country yet. And even in places where that data is being collected, the practices for interpreting it aren't necessarily well developed at this time. And then finally, load flexibility is obviously a huge question in large loads. And at this point, we did not identify really any forecasts that were including load flexibility in a meaningful way for future large loads. So developing those practices is definitely going to be complicated, but it's an area where we need to continue to evolve. And with that, I think I pass back to you, John.
Great, thanks. So the first thing we wanted to talk about in terms of our recommendations is an area that we've sort of grouped here as lack of consistent definitions. And one of those is these forecast metrics that we identified. And we've listed them here, and I'll just kind of go through them briefly and talk a little bit about why they're so important. None of them are particularly rocket science, but we were surprised at how much variation we saw in sort of the even which of these metrics might be used in load forecasts across the country, and whether some of them in some cases were kind of combined together, sort of grouped together into a single metric. So project realization is just simply whether the project, the large load project, whether it's a data center or a manufacturing facility or whatever, is going to move forward or not. Often that will be expressed in a load forecasting calculation as a percentage of project requests that are expected to come to fruition. The next one is the energization date, and that would be simply the beginning of commercial operation by the projects. And again, in a forecast, you might include sort of anticipated delays in that calculation. Next is load realization. Here's, if a utility, or excuse me, if a customer says, I would like 500 megawatts, please. And the utility says, great. The utility may know that over a group of projects, probably not all of them are going to all turn out to need 500 megawatts. It may need only 400 megawatts. And so you see adjustments being made in that area as well. Next is load ramping. So it's a fact that in general for large loads that the load does not come online all at once. It may take a number of months or even years for the project to reach that full load realization that we just talked about before. So you'll have a schedule, a monthly or annual schedule of how quickly that load will come online. And then finally, we look at sort of the energy side. The first four are mainly focused on kind of the peak demand. But then we need to know the load factor, or ideally the load shape. So how much energy use there will be as a proportion of the actual facility capacity in any given month or year. And then the load shape would include ideally an hourly schedule of energy use. So each of these metrics should sort of be dealt with ideally separately in preparing the overall load forecast. What we see in a few cases is that some of these will be mixed together, like the load realization And the project realization might be mixed together so that you just see sort of an expected load, and you don't really know how much of that is due to projects coming in smaller versus projects just not simply being completed. It could even be mixed in with the energization date where you assume a delay. And so you have a project pipeline that has, 800 megawatts in 2027, and instead the project forecast is 500 megawatts in 2027. And you really don't know whether that's due to delays in the projects that are anticipated by the utility, the project simply being canceled, or the load just coming in lower than expected. So there can be a lot of different factors, and breaking them apart into these 5 metrics is kind of one of our key sort of definitional recommendations to the industry. Second is we really think there needs to be more standardization of the large load interconnection milestones. It will probably not be identical across all of the country, but you will see, from the point of customer information all the way through to the end where we've got the project online and energized, and then you begin to monitor it. You need to sort of mark out at what points, what are the expectations at each point, and how that then relates back to the load forecast. So a project that a customer says will be 500 megawatts on day 1 might later, when the interconnection request is filed, might be slimmed down to 400 megawatts. And then maybe by the time the electric service agreement is signed, maybe it's only 350 megawatts. So you'll see that progression, and that has a real impact on the interconnection work that the utility does, as well as planning for long-term future transmission and generation resources. So those are kind of the 2 big key themes. Next, we picked out 3 recommendations that we did want to highlight before we go to the poll and see kind of what the audience is really most interested in. So the first one is addressing back-end risk. And this is an issue that we see is not being addressed at all in any of the load forecast documentation we were able to review across the country. Now, we've all heard a lot about front-end risk. And that's, of course, whether or not the project is actually going to come online and if it will be as large as the customer says it will. And those are all addressed in those metrics we just went over a moment ago. But the back end risk is really just not addressed at all. And so, for example, existing projects that are out there and get built may disappear later in the forecast period. Most, if not all, load forecasts assume that projects that come online will stay online basically indefinitely for the duration of the load forecast. If demand falls below expectations, that could lead to stranded transmission and generation investments, which affects all customers, depending on the tariffs and financial security guarantees that have been given. And those tariffs that provide those protections will address some of those issues, but they do not eliminate risks to the utility system or its customers. Another thought that a lot of people have had is, well, maybe as projects attrition occurs, there may be other future load growth that comes in and sort of fills that gap in. And one of the questions is that load growth going to be well matched to any project attrition? Something that really just has not been studied. Is it in the same location? If you've got a large data center built out in a very rural area and your load growth is in an urban area, maybe the transmission development that's occurred to support that project isn't really very well designed to meet the needs of future load growth. So those would be concerns that we have with that. Sophie, you want to handle the next one?
Sure thing. So this really follows along from our area where there's room for improvement, which is in terms of data availability. And as we noted, a lot of the utilities simply don't have the historical data to inform their professional judgment and their forecasts. So without data sharing, the default option is really for those utilities to wait a number of years, do some things right, do some things wrong, gain experience, gain data. And obviously, it would be better to have more data sooner. There are clearly barriers to data sharing, specifically customer privacy is a main barrier. EPRI has made some progress in obtaining data, but is not able to share that widely at this time. So there's really a need for a database of some kind of anonymized data that can help utilities and other planning entities inform their forecasts. The first steps would be to collect data where possible. Some of this needs to happen at the forecast level, just in terms of the forecasters actually collecting more data from customers upfront. And we can really focus on the simplest metrics first. So that project realization, load realization, and energization date data, understanding how those change from initial requests, and then being able to share that would be really helpful. Also, definitions of the large load types to understand which types of loads are more similar to each other, which we can treat as larger categories. And then as we gain more information and more experience, we would want to add complexity to the database, including information on load ramping, load factor, in terms of how the loads actually perform throughout the year, hour by hour, and then any additional data that becomes available, such as the flexibility data that we've talked about. And having more data will both allow forecasters to look forward with more certainty, but then also allow us to do more validation of forecasting practices so that we can continuously improve. John, I'll pass back to you.
Great, thanks. The final recommendation we wanted to flag is what we're calling a maturity assessment framework. And this actually came out of some a preliminary draft reliability guideline from NERC, which recommends that utilities use project milestones to assess project maturity. So we talked about those milestones before, but simply translating that into a decision about weighting factors and about the forecast accuracy range, that's a complex process. And so we suggested here borrowing from the AACE cost estimate classification system. And this is something that many people who are involved in capital projects in the utility industry will likely be very familiar with. And as you can see here, you start out with projects that are sort of classified as class 5 and then progress towards, very detailed advanced development projects that are class 1. And as that progresses, the contingency number that is used, the contingency percentage that's used for the budget in a cost estimate system gradually gets smaller, gets to be maybe go from plus or minus 100% down to plus or minus 10% for a very advanced project. And similarly, we're suggesting that we develop a very consistent maturity assessment framework that sort of defines what kind of a project is, what kind of a large load project fits in a class 5 category, and then what sort of information is needed to advance it to class 4, to class 3, and so forth. And so with each of those steps, as you add additional detail to the project, you become more confident in the load and you can assess it. And the reason for coming up with such a framework, rather than each utility just sort of creating this process kind of entirely ad hoc, is so that there's some consistency across the industry in understanding what practices are being used and how they're being applied. We're not suggesting that this be a uniform one-size-fits-all process, and the AACE cost estimate classification system is not such a process either. It's more a matter of beginning to develop a common set of understandings and exchange information among load forecasting practitioners as to what's useful for defining this, and then helping that inform not just the load forecast, but also other aspects of the transmission and generation planning process, other aspects of the interconnection request review and construction process, and so forth. So it would be tied into really broader activities across the utility. But it's, motivation here is to really help with defining the load forecast. So we're hoping that this suggestion will help advance the industry and that there'll be some work done around that. With that, I want to thank you for being a part of this pre-release presentation. And True, do we have sort of a winner in our poll? Is there one of the recommendations that you want to pick out from the top that you want to stump me or Sophie with here?
Yeah, we'll get to that. Thanks, John and Sophie, for the efficient presentation that gives us, plenty of time for lots of Q&A. So just as a reminder, if you haven't done so already, get on slido.com, use code ESIG17, answer put down your questions or vote for the questions there or answer the poll. Before we get to the poll, John, there is a clarification question in there to explain the relationship between project realization, between the forecast and the pipeline. It reads like project realization encompasses the pipeline and project requests. Can you elaborate on that a little bit more?
Yeah, I think the project realization, all of these metrics are applied both to the pipeline and even in some cases to projects that maybe haven't even contacted the utility. So if you're thinking about a project that's, your load forecast, excuse me, for the 2035 to 2040 timeframe, you've got to think there about projects that may not have even contacted the utility. Do you expect projects in that time range? So the project realization is really about both existing contacts, whether it is a customer inquiry or a customer that has already filed an interconnection request, or one that has even progressed through that and has even signed an electric service agreement. And if the project is, at the earlier stages, your project realization rate may be very low. You may assume a 5 or a 10 or a 15% project realization rate. Even for projects that have signed contracts, you might choose not to assume 100% project realization rate. If you have some experience that projects during the construction phase sometimes have significant financial changes. And that could be, for example, if they're very dependent on federal policy issues, and those policies change during the project's latter stages. So you could see project realization rates, 100% or 90% or whatever you might choose, but that would vary across the life of the project. And then if you have a forecast for additional projects in the future that you anticipate, as some utilities do, you might also apply a project realization rate to that and assume that, if you're forecasting that, you're going to continue to see 25 inquiries per year through 2040, maybe you assume some attrition rate for those or a project realization rate for those that reduces that number to the actual projects being developed to be significantly lower than that. So I hope that addresses the question.
Yeah, thanks. Thanks, John. We'll have some more questions, and please do keep them coming. I think for the poll, the winners are around uncertainty. So both just accounting for uncertainty overall, which you've touched on a bit on the back end risk, but maybe you could elaborate a little bit more on that. But particularly on regional uncertainty for regional practices. So if you could touch on those two, and then we'll get to the next one.
Great. Sophie, why don't you take the regional question first? I think that's a great one to start with, since we haven't really touched on the regions yet.
Yeah, definitely. I think, there's a lot of ways to approach the question, but first off, just to go back to the grid strategies report that we put out recently on load forecasts across the country. We aggregated the load forecast from the various planning entities and then compared the breakdown of data center load forecasts across the country, which we saw about 90 gigawatts based on the number of filings, to forecasts from the rest of the industry. Folks from Wall Street, numbers based on chip shipments, folks who are tracking specific projects. And based on our analysis of those numbers, we do suspect that the utility and other planning entity estimates are probably overstating data center load forecast by about 25 gigawatts, which is really, I bring up to highlight that there is a lot of uncertainty. Unfortunately, while we're identifying that number on a national level, that really doesn't help a single planning entity know how much of that load is going to end up in their region. So I say that to highlight that this is a really hard challenge. And I think that part of why we wanted to compare all of these is to really assess the best practices and also just bring to the fore some of these specific metrics that are leading to this uncertainty. So that isn't a good way of telling us how to address that uncertainty, but at least gets us towards knowing where we can improve. And John, I'll let you add to that.
Yeah, sure. So I'll tackle let me jump to an extra slide here we have, and this is from a draft version of the paper. We're going to enhance this graphic a little bit. But when you're talking about regional planning, which was one of the questions there, we found that there's a few different approaches that are being taken by the regions. And here we've included the California Energy Commission, or CEC, along with other regions that you might traditionally associate with the word region in the US. And there's the two main methods that are being used right now are either a post hoc adjustment or a scenario overlay. And in those two approaches, the region aggregates the member forecasts and then makes an adjustment. And in the post hoc adjustment, it's just simply adjusting the large load additions number in general downward. Generally, there's a consideration of whether maybe the base forecast already includes some of that load, or whether some of the load may simply be more uncertain in the region's view than maybe the utility felt. And so you're seeing those adjustments. The other approach that's being taken is to adopt a scenario overlay where you make those adjustments, but you make them at different levels. So you might have a low, medium, high scenario. What we're also seeing emerge across a number of these regions is what we're calling a regulatory approach. And so in this case, the regulatory approach is for the region to say to the load serving entity or utility, basically, here are the practices that we would like you to apply in forecasting your large loads, and the weighting factors that are applied. So going back to, and I'm sorry, I'll skim through back to the metrics here. So going through the metrics, what are the weighting factors that you would apply to project realization, load realization, and so forth in each case? And then at which point in the process, is the project at the interconnection request stage, or has it progressed through and does it have an electric service agreement? So getting more consistency across the utilities within the region in terms of how they're applying weighting factors to the proposals from the customer to come up with that load forecast. And so that's kind of the general approach. Sam, I see you've come off mute here. Do you want to jump in and kind of weigh in from ERCOT's point of view on this?
I was actually accidentally hit on mute, but yeah. No.
So you're on the spot anyway.
Yeah. No, the regulatory portion has been, it seems to be gaining traction across not only the US, but abroad as well. And, it is a bit of a cumbersome process, but, I think it also levels that playing field for everybody. So everybody is applying the same rules. So I can't just go to you because it's advantageous to me.
Thanks, Sam. Yeah, I appreciate it. And I think one of the key phrasings that we chose in the report was to use convergence or consistency and not necessarily uniformity. So I don't think, for example, PJM is expecting every member utility to do exactly the same thing, because I've got these milestones up here and many utilities have slightly different milestones. They might break the letter of authorization up into a couple of stages. There just may be different touch points. And so the main goal here, I think, in the regulatory approach is to have a lot of consistency in a view so that a customer that, say, initiates two projects with exactly the same characteristics and intention and finances is treated the same roughly from one utility to the next. Even if it's in a different service territory, it's going to be sort of treated the same if the project is very similar. So that's kind of the idea there. Drew, what else do you have for us?
Yeah, so just on this topic, there were some questions related to, are you observing differences in kind of RTO level forecasting versus vertically integrated utilities? If you could speak to any kind of general classifications there. And I'll just add another one to that. which is the questioner asks, how do the regional forecasts deal with load shopping is the term used there. I think you touched on that a little bit there, but if you could speak to that as well.
Yeah, so I mean, I think we found that there's really sort of differences between the regions and the utilities in terms of what they're expected to do. The utilities are the ones who are in direct contact with the customers for the most part. Many of the regions do not have any direct contact with load interconnection customers for purposes of load forecasting, or if they do have that kind of information flowing directly from the customer to the load forecasting team, it may be limited in some way. It's really a lot of that responsibility is at the owner of the transmission facility that's being interconnected to. That's kind of where that information is housed. So you see a real substantial difference in kind of how the forecast is built. As we noted before, most of the regions aggregate their load forecast up from the member utilities, particularly when it comes to the large load forecast portion. So for example, PJM has a base forecast that is constructed on a regional basis using econometric methods, but it gets its large load adjustments from each member utility individually and then aggregates them up for the whole system. So that's kind of how that's handled. Sophie, why don't you handle the second part of that question?
On load shopping, I think that it's an open issue. We're definitely seeing practices like in ERCOT where they're following SB6. There was the requirement to disclose if any developers are looking in multiple jurisdictions. So that's a really big step, I think, and I would expect that we're going to see that kind of request and requirement in more jurisdictions, given that this is a known issue. I think there are definitely some utilities that require and ask their customers if they're looking other places. How efficient or how effective is that, I think remains to be seen a bit. But certainly it's something that folks are working on. But I think, as we noted, how to actually use that information is also still up in the air. So for instance, if you are a utility and you hear from a customer, yes, I'm looking in 2 other locations, does that mean we assume that there's a 33% project realization rate? Do we assume it's lower? Do we assume it's higher? I think that that's something where we also still need to develop best practices.
All right, thank you, Sophie. And Sophie, I think you mentioned earlier, this is one of the top ones on the poll as well, that load flexibility, we really didn't see, you didn't really see any of that considered in the load forecast that you looked at. Can you speak to what this team would recommend around load flexibility and get into as much detail as you can on that?
Yeah, I'll start us off and then pass to John. I think in our discussions, a big part of what we talked about was how much of load flexibility actually should be addressed in the load forecast. Certainly, we see programs like very successful demand response programs across the country that treat that kind of flexibility and demand response as a generation resource more than as an impact on load. On the other hand, when we're looking at transmission planning for peak load conditions, we certainly want to know if we're building a line for a specific entity, how flexible it can be and respond to things like thermal constraints. So at this point, I think one of the biggest recommendations, as we will say many times, is to collect more data and start collecting behavioral data. And then also just to think about what kinds of requirements can actually incentivize flexibility from these customers. So I think, True, in one of our previous conversations, you coined the term carrot sticks, which is to say that we often think of a demand response program as a carrot that can incentivize flexibility. And then increasingly across the country, we're seeing entities start to require flexibility as a requirement for more rapid interconnection of loads. So I think we expect to see some combination of those start to drive these loads towards flexibility, but the extent to which that will be successful remains to be seen. And John, I'll pass to you to talk a little bit more about how we want to incorporate it into load forecasting.
Yeah, from the point of view of incorporating load flexibility into forecasting, one of the challenges is just simply we need to create definitions for those terms. and those don't really exist yet. There's a lot of different kinds of load flexibility. We don't have a slide on this, unfortunately, but there's a EPRI has put out sort of 5 tiers of load flexibility. I think we'll see other kinds of lists of load flexibility emerge from NERC and others over the coming year. So I think that, you know, when you're thinking about load flexibility, you've got to sort of recognize that in some cases it's not even relevant to the load forecast if it's just simply short-term support for the grid. But if it's long-term dispatchable capacity, then that's absolutely relevant to resource planning and transmission planning. And ideally, you would want that to be done in a consistent way. Now, there may be different questions that transmission planners versus generation planners or market forecasts are thinking about generation or thinking about load flexibility, but you want to have a consistent set of data that is being drawn from to then inform those studies and decisions that are made.
Yeah, thanks, John. You may have a backup slide on the EPRI 5 tiers. It's up to you if you want to show it. But just to follow on the carrot sticks a bit here, one of the questions is around, you know, what can or should utilities expect out of data center flexibility? Is it what the data center developers say they can provide, or should utilities push more for the flexibility on the interconnection solution? I know there's a lot of discussion and commentary on this. Maybe getting your thoughts and how it dovetails with forecasting would be great, further than what you've already elaborated on.
Yeah, thank you for reminding me that we did have that slide. I remembered putting it together and I forgot that we ended up dropping it in the back. So I'll let people kind of review that as I chat here. I think that, you know, the first fundamental question is that a lot of demand flexibility is really evaluated more as a supply side resource in terms of how it's modeled. And in that case, it really just doesn't even go in the load forecast. And so we're going to see some utilities or regions that just simply would prefer to have a very simple peak load forecast and a load shape forecast that is the demand of the facility without any load flexibility. And then they'll ask questions about the load flexibility in order to determine how it affects what kind of resources they need to build, whether it's transmission resources or generation procurements themselves. So that's kind of the basic practice that we identified. We did not go too much further than that in the report. So it is an area that I think we're waiting for other areas of large load practices to develop in before the load forecasting practices kind of react to that. I think that it is a little bit, the load forecasting, I don't think is going to drive how load flexibility is built out. I think it's really more a matter of interpreting decisions that are made and putting them in the proper context for planning purposes.
Thanks, John. And that's a perfect segue to our next question, because load flexibility is complex, emerging. I don't think there are many answers at this point. But one of the questions before we get to flexibility is just, do you have recommendations for forecasting base load versus peak load? This is one of your load shape questions there. What should be some important factors to consider for one versus the other? So not necessarily flexibility, but just the shape and the energy versus capacity type questions.
Yeah, Sophie, you got thoughts on that?
It's a tough one because I think load shape and load factor right now are some of the metrics that we know the least about. So I think that, you know, this comes down really to understanding those better, which again brings us back to my pet issue of data sharing, data collection. But I think most of the forecasting practices right now are really focused on better understanding what that peak load is going to look like, since that's driving, you know, needs like transmission planning in particular. And then as we get to better understand what the load shapes will actually look like, we'll have more information there. I think one of the things we've found is that a lot of utilities that have less experience with data centers assume very high load factors, some of them up to maybe 100%, which is probably too high for data centers. But on the other hand, data centers do have much higher load factors than many other types of loads, so it is important to differentiate. And important to differentiate, as we noted, between various types of large load so that we can gather more information and make better assertions there.
Yeah, I think the one thing I'd add to that is that the load shape, finding a good illustration of load shape data was one of our biggest challenges just in writing the report. Very few utilities or regions have published specific load shape data. The one graph we have in our report is actually from ERCOT, so thanks, Sam, for getting that information out into the public. Really appreciate that. And so you can get a sense from that graph as to how different kinds of, and I definitely don't have that in the presentation, but you can take a look at that graph when the report is published, and you can see that different types of data centers have different load shapes. And that doesn't even touch on the differences between an industrial facility or an oil and gas facility or a data center, you know, comparing those even broader categories. And so there's a lot of difference there. And this is one of the key reasons, as Sophie mentioned, that we really recommended developing a shared database across the industry. And as we mentioned, EPRI is a place that has begun to collect some data from some of the participants in its DC Flex initiative. But I think a lot more needs to be done. And this is something that, you know, it's beyond the capacity of an organization like ESIG or beyond the capacity of really any individual utility or region to collect and serve as that resource for all of the participants in the power industry who need information on these topics. Another big challenge with load shape is that many of these facilities will simply not know their load shape before they're built. You know, historically, if you go back 5 or 10 years and you're bringing online a new factory or even a new, say, a crypto mining facility, you're going to have a lot of precedence for those kinds of facilities. But what we're seeing right now is a lot of innovative technology. AI is certainly the most obvious example of that. But even in the industrial space, many of the facilities that are being proposed to be built will have unique and different load shapes than really any predecessor. And so it's kind of the sheer quantity and scale of the novelty in the industry that is creating a challenge here on these load shapes. Because while, you know, if you had one novel facility coming online in 2011, that might not have been such a big deal. But now you've got utilities that are dealing with, you know, 4 or 5 or 10 or maybe even 50% of their load is going to be from novel facilities. And they have little idea what the load shape is going to be beyond sort of informed speculation from those customers.
Thanks, John, Sophie. I think, you know, this audience or the participants here tend to want some quantitative numbers, and I know there's a lot of moving pieces here. But from your grid strategies analysis, with looking at the utility and regional forecasts, what are some of the implied load factors that you're seeing from those forecasts? And Sophie, you spoke to this a little bit.
Sophie, why don't you start that out, and I'll actually pull up a slide from that report since we're getting asked about it.
Definitely. So this was honestly, from a grid nerd perspective, one of the most interesting things that we found in our analysis of the utility and planning entity forecasts, which was that, you know, when you look at the increased gigawatts versus the increased gigawatt hours, the implied load factor is quite high. And John, correct me if I'm wrong, but I think it was 96% load factor. And part of that is driven by areas like New York, where we're seeing a lot of increases in winter heating load, for instance. NISO actually has a more than 100% load factor in their forecast. But a lot of that is also driven by utilities and their very high load factors. Data centers and their very high load factors. So as I noted, you know, data centers do have quite high load factors compared to other loads, but that it looks like, based on our analysis, some of them are assuming load factors that are even higher than they should be, around 100%. But John actually did a lot of this analysis, so I'll pass it to him now that the slide's up.
I think, Sophie, you've covered it pretty well. There's the graph on the right on the slide I just brought up here, and you can see there that every region in the country is growing, energy use is growing faster than peak load. And so I think that's kind of a little bit at odds with some of the public narrative that is focused very much on the peak load. And, it really actually taps back into all the questions about load flexibility. Load flexibility is great for addressing peak load, but it doesn't help much at all with addressing energy use. If you don't have enough energy out on the system to supply the load, it doesn't matter how much you can move the load around or move the energy around. You're just short. And so we've got to get the energy growth up very quickly, even more quickly, it appears, based on these forecasts, than the peak load. So I think that was one of the surprising findings in our grid strategy study that we just recently released. Hasn't gotten as much attention as some of the other findings in that report, but one that I think needs a lot more scrutiny in the industry. Are these, and certainly the first question is, are these forecasts right? I mean, we are presenting the forecasts as they are delivered to us from the source, and has enough thought gone into the question of load factor and load shape? And I think those are the key questions. So rather than sort of honing in and sort of checking the math, is it 96% or is it 94%? I think a lot of sort of fundamental questions about how these numbers are being developed right now need to be asked within the industry. And again, a lot of this is very new, so we're not pointing fingers and saying that people are doing things wrong on purpose. We're saying that they've moved quickly to respond to a very rapid evolution in the industry. And it's time for self-reflection on those decisions that have been made, and try to improve practices as we move forward.
Thanks, John. I appreciate you jumping around the slides as well. There's a question here on, are there utilities or entities you think are doing a good job of forecasting or doing it poorly? I don't think you need to answer that. Essentially, the process here is to take the examples, and I think we're drawing from the innovative practices across the industry in the report. And so we have listed a lot of examples from those innovations. John, Sophie, I don't know if you want to add more to that.
Yeah, I'd love to jump in on that.
Yeah.
Just to say, I mean, I think that there are a lot of utilities and planning entities that are doing a really good job. We've talked about PJM and ERCOT taking this more regulatory approach to get more consistency, and I think those are really valuable efforts. And then I think there's certainly utilities that have very sophisticated approaches to modeling. I think, we showed that Dominion slide. And they have a very complicated, very evolved approach based on the fact that they have a lot of historical data. And while we can hold that up as an example of a utility doing a really good job, it's not necessarily applicable to other parts of the country and other territories. So I think one of our findings is that frankly, it's not a one-size-fits-all approach, and that utilities can learn from each other, but that certainly the Dominion approach isn't going to be relevant to areas of the country that have fewer data centers, that have fewer years of history, so that while they can learn from it, we're not trying to say that everybody should be doing what Dominion is doing.
John, anything to add?
No, I think Sophie covered it great. Thank you.
Great. I'll ask one more that's a little bit different direction here, which is, how well do you think large load tariffs are providing protection to ratepayers? You spoke on this about back-end risks, John, so maybe anything more to elaborate?
Well, this is not a focus of this report. I'll comment on it a little bit. First of all, I believe that Lawrence Berkeley National Lab is going to be doing a complimentary report to our projects that covers that topic. And so I'm looking forward to hearing what they have to say. I do, in other work, have the opportunity to participate in some of these proceedings. And I would say that I think that we're seeing a lot of improvement in how large load tariffs are being developed. A good example from sort of a structural perspective is the Dominion, Virginia approach that was recently approved. I think it has a lot of the right elements, and it's relatively transparent in terms of how it addresses these issues. I do, however, still have the opinion that it was not as consumer protective as it could have been. And I think one of the key factors there is term length. We're seeing investment lifetimes of 25, 30 years that are being made, both at by the customer in terms of its financing, and by the utility in terms of investments in transmission and generation infrastructure. but we're seeing term lengths that are 15 years or 10 years for the contracts. And I think that's a mismatch that creates a big long-term sort of back-end risk for customers. And that's one of the, kind of conceptual reasons I think that we focused on back-end risk in this report, to highlight that needs to be better understood as to what are the planning and eventually financial risks that are being taken on by utilities with tariffs that have a relatively limited contract duration requirement. So that's something to kind of flag, but I don't think we can answer that question fully because that wasn't a topic that we dug deep in here.
Great. And we're at the top of the hour. There's a lot of other questions that we'll get to subsequently here, and we'll post responses to those. But we really want to thank John and Sophie for the webinar today. As I mentioned, an email will go out with the video file, and we'll post them along with the answers to the questions we didn't get to. We really appreciate your engagement. Look forward to seeing you again, perhaps in January in the new year, where we have other very informative webinars already planned. Go to our events page. And we hope to see you in Tucson, Arizona at our spring technical workshop during the March 15th week. esig.energy under events, and you can find it in our newsletters and mailing lists as well. Thanks everybody for your attendance. John, Sophie, Sam, thanks again for this timely and informative webinar. And we look forward to seeing you all again in the near future. Thanks,
and
everybody.
True, before we sign off, I want to just once again thank everyone on the project team. We had a lot of great participation, as I mentioned, 17 existing practice webinars, 6 project team meetings, and a lot of engagement in the editing. So we had we drew a lot of professional satisfaction from learning from and engaging with all those folks. And then also, especially the team at ESIG, the staff there have been terrific to work with. I think we've got a great product that's going to be, I hope, of great use to the whole industry. And it was a real professional privilege to be a part of this project. So thank you to all of those folks again.
Appreciate that, John. And thanks, everybody. We'll be in touch.
Thank you, everyone.